Boston Dynamics. Just the name alone sounds like a group of mastermind geniuses from a science fiction movie. But unlike some of the videos on the internet, every robot featured in this video is a real creation by Boston Dynamics. Although not all of their creations are useful in everyday situations, it still amazes me just how far Boston Dynamics have come since they began in 1992. The company, which was founded by Mark Raybert, who spun the company off from the Massachusetts Institute of Technology in 1992. Early in the company's history, it worked with the American Systems Corporation under a contract from the Naval Air Warfare Center Training Systems Division to replace naval training videos for aircraft launch operations with interactive 3D computer simulations. On December 13, 2013, the company was acquired by Google X for an unknown price, where it was managed by Andy Rubin until his departure from Google in 2014. Immediately before the acquisition, Boston Dynamics transferred their DI-Guys software product line to VTMach, a simulation software vendor based in Cambridge, Massachusetts. But on June 8, 2017, Alphabet Incorporated announced the sale of the company to Japan's SoftBank Group for an undisclosed sum. Then on April 2, 2019, Boston Dynamics acquired the Silicon Valley startup Kinema Systems. And finally in December 2020, Hyundai Motor Group acquired an 80% stake in the company from SoftBank for approximately $880 million. SoftBank Group retains about 20% through an affiliate. Now let's take a deeper look into the robots the company have made. The Cheetah is a 4-footed robot that gallops at 28 miles per hour, which as of August 2012 is a land speed record for legged robots. A similar but independently developed robot also known as Cheetah is made by MIT's Biomimetic Robotics Lab, which, by 2014, could jump over obstacles while running. On June 23, 2016, Boston Dynamics revealed the four-legged canine-inspired Spot, which only weighs 25 kilograms, 55 pounds, and is lighter than their other products. Spot is an agile mobile robot that navigates terrain with unprecedented mobility, allowing you to automate routine inspection tasks and data capture safely, accurately, and frequently. The agile anthropomorphic robot Atlas is a 6-foot, 183 centimeters, bipedal humanoid robot, based on Boston Dynamics' earlier Petman humanoid robot, and designed for a variety of search and rescue tasks. In February 2016, Boston Dynamics published a YouTube video entitled Atlas, The Next Generation, showing a new humanoid robot about 5'9" inches tall, 175 centimeters. Atlas's advanced control system and state-of-the-art hardware give the robot the power and balance to demonstrate human-level agility. Atlas has one of the world's most compact mobile hydraulic systems. A custom battery, valves, and a compact hydraulic power unit enable Atlas to deliver high power to any of its 28 hydraulic joints for impressive feats of mobility.
Atlas is the culmination of over a decade of hydraulic humanoid robotics work at Boston Dynamics. Atlas stands about 5 feet tall, weighs about 190 pounds. It's battery powered and hydraulically actuated with 28 degrees of freedom. It has RGB cameras and depth sensors, which provide input to its control system, and all of the computation required for control, perception, and estimation happens on board its 3 computers.
At a practical level, it's a platform for us to do R&D on, and as an Atlas team, we're encouraged to push that platform to its limits, like do the most crazy, exciting, high power stuff we can do with it. And so we're always expanding and pushing the limits of Atlas's capabilities, and then, hopefully by extension, extending the capabilities of the company as well at the same time.
Parkour is a useful organizing activity for our team because it highlights several challenges that we believe to be important. First, how do we build a high power density mobile robot that's capable of extended athletic behavior? How do we design control algorithms that can create a variety of behaviors and control them robustly? And how do we connect perception to action in a way that both captures long-term goals like getting from point A to point B and short-term dynamic goals like adjusting footsteps and applying corrective forces to maintain balance?
So where does the future lie for these amazing robots? Well, NASA scientists have an unusual idea for exploring the surface of Mars by sending a four-legged robot dog. Specifically, researchers suggested that a modified version of Boston Dynamics dog-like Spot robot would make for a great alternative to the classic Mars rover. So it would seem that a future where we send humanoid robots into outer space to explore the universe is the most likely and exciting outcome these amazing machines can reach. Thanks for watching, everyone. I would appreciate the support, guys. If you could drop a like and comment. Until next time, guys, stay educated. Welcome back, guys. And in today's one we take a look at the fascinating science behind Atlas from Boston Dynamics. Atlas is the most dynamic humanoid robot currently on the market. Its state-of-the-art hardware gives the robot the power and balance to demonstrate human-level agility. The robot has one of the world's most compact mobile hydraulic systems. The custom battery, valves, and a compact hydraulic power unit enable Atlas to deliver high power to any of its 28 hydraulic joints for impressive feats of mobility. Atlas's advanced control system enables highly diverse and agile locomotion, while algorithms reason through complex dynamic interactions involving the whole body and environment to plan movements. The robot uses 3D printed parts to give it the strength-to-weight ratio necessary for leaps and somersaults. By training Atlas to maneuver its way through complex parkour courses, Boston Dynamics engineers develop new movements inspired by human behaviors and push the humanoid robot to its limits. Let's take a look at how Boston Dynamics are building a foundation with Atlas. A robot's ability to complete a backflip may never prove useful in a commercial setting. But it doesn't take a great deal of imagination or sector-specific knowledge to see why it would be helpful for Atlas to be able to perform the same range of movements. If robots can eventually respond to their environments with the same level of dexterity as the average adult human, the range of potential applications will be practically limitless. Humanoids are interesting from a couple perspectives, Koindersma says. First, they capture our vision of a go-anywhere, do-anything robot of the future. They may not be the best design for any particular task, but if you wanted to build one platform that could perform a wide variety of physical tasks, we already know that a human form factor is capable of doing that. From a technical perspective, humanoids present several challenges that we welcome as a research team, he adds. Their combination of size and complexity creates hardware design trade-offs related to strength-to-weight ratio, runtime, range of motion, and physical robustness. At the same time, our control team has to create algorithms that can reason about the physical complexity of these machines to create a broad set of high energy and coordinated behavior. Ultimately, pushing the limits on a humanoid robot like Atlas drives hardware and software innovation that translates to all of our robots at Boston Dynamics. Parkour, as narrow and specific as it may seem, gives the Atlas team a perfect sandbox to experiment with new behaviors. It's a whole-body activity that requires Atlas to maintain its balance in different situations. It's really about creating behaviors at the limits of the robot's capabilities, and getting them all to work together in a flexible control system, Koindersma says. There are many important problems that parkour doesn't force you to address, but that's not the point. We're not trying to solve everything all at once. The work we're doing now is allowing us to create a solid foundation. Looking back over 5 years of Atlas videos, it's easy to lose sight of just how much progress the team has made during that time. In fact, some of the improvements are invisible to the average viewer, even though they represent giant leaps in technology. Atlas's moves are driven by perception now, and they weren't back then, Koindersma explains. For example, the previous floor routine and dance videos were about capturing our ability to create a variety of dynamic moves and chain them together into a routine that we could run over and over again. In that case, the robot's control system still has to make lots of critical adjustments on the fly to maintain balance and posture goals. In this iteration of parkour, the robot is adapting behaviors in its repertoire based on what it sees. This means the engineers don't need to pre-program jumping motions for all possible platforms and gaps the robot might encounter. Instead, the team creates a smaller number of template behaviors that can be matched to the environment and executed online. Simulation is an essential development tool for the Atlas controls team, both for evaluating new behaviors prior to robot testing and for ensuring that new software changes don't negatively impact existing capabilities. But there's still no replacement for hardware testing, particularly in performance-limiting motions like vaulting. About that vault. Unlike high-flipping gymnastics vaults, a parkour vault is a slightly less flashy method, designed to get a runner over a low wall or obstacle. In this case, the balance beam, only a few feet high. Atlas places its arm on the beam and then hoists its body over the structure. For many humans, this sort of vault would be relatively easy. But for the Atlas team, it represented a formidable new challenge. If you or I were to vault over a barrier, we would take advantage of certain properties of our bodies that would not translate to the robot, Koindersma notes. For example, the robot has no spine or shoulder blades, so it doesn't have the same range of motion that you or I do. So guys, I hope that demonstrations like this provide a small glimpse of what's possible. So where do you see the future of Atlas? A robot for show or a marketable product adopted by humanity? Please leave your opinions in the comments and have a good day. So guys, I hope that demonstrations like this provide a small glimpse of what's possible. So where do you see the future of Atlas? A robot for show or a marketable product adopted by humanity? Please leave your opinions in the comments and have a good day. If you haven't met the four-legged robot yet, then this is Spot. The robot that navigates terrain with unprecedented mobility, which allows you to automate routine inspection tasks and data capture safely, accurately, and frequently. Spot can carry and power up to 14 kilograms of inspection equipment. You can control the robot from afar using an intuitive tablet application and built-in stereo cameras, using a controller which resembles the Xbox One pad. The program is used on repeatable autonomous missions to gather consistent data. But Spot is more than just a mobile robot. It's a mobile sensing platform that developers can customize with software, sensors, and other hardware payloads to achieve precisely what they need for specific applications. Whether it's building the tools to explore other planets or to inspect work sites, the ability to easily build on Spot's base functionality has huge real-world value. This flexibility also opens up opportunities for more creative applications. For example, Spot has a long history with alcoholic beverages, from inspecting breweries to doing many other activities with beer. But before all that, there was Margarita Spot, an internal project developing a Spot payload that blends the perfect margarita. Margarita Spot is basically what you would expect from the name. It's a custom payload that adds a Margaritaville drink machine to Spot's back. You add the ingredients and Spot does the rest, crushing the ice, blending the mix, and delivering a mobile margarita. Through the payload API, we program the settings for the drink machine, as well as custom configuration for Spot's balance and behavior when it's in use. Margarita Spot dates back to early 2019. It's actually one of the earliest Spot payloads ever implemented. But Spot was designed for more than mixing cocktails. As NASA scientists have an unusual idea for exploring the surface of Mars, sending a four-legged robot dog to do so. Specifically, researchers suggested that Spot would make for a great alternative to the classic Mars rover. The idea is that they're better suited to cover long distances and rough terrain, and could even help map out possible locations for the type of human outposts that NASA hopes to eventually establish on the Red Planet. Scientists are already testing out the idea, equipping Spot with new gear that could help it navigate and plot its surroundings. The prototype RoboDog, nicknamed O-Spot, would be able to cross terrain that's inaccessible to a wheeled rover and do so much faster, while also hiking around obstacles and standing back up if it falls over. The NASA scientists said, using recovery algorithms, the robot can self-right from a multitude of falls. Spot's mission on Mars would be to explore and develop maps of Martian caves and tunnels, but for now, it's doing test runs in hallways and tunnels that mimic Martian terrain in California. His state-of-the-art robotics company, Boston Dynamics, recently sold 80% of the company to Hyundai Motor Group. Hyundai Motor Group is the second largest Korean conglomerate after Samsung, and it's the world's third largest vehicle manufacturer. Hyundai Motor Group owns the Hyundai Motor Company, the company that actually makes Hyundai branded cars, along with Kia Motors. By establishing a leading presence in the field of robotics, the acquisition will mark another major step for Hyundai Motor Group toward its strategic transformation into a smart mobility solution provider, Hyundai Motor Group said. To propel this transformation, Hyundai Motor Group has invested substantially in development of future technologies, including in fields such as autonomous driving technology, connectivity, eco-friendly vehicles, smart factories, advanced materials, artificial intelligence, and robots. Since Hyundai Group took over, production of Spot has ramped up fivefold. With Boston Dynamics announcing they will now sell any business its own Spot robot for $74,500. It's a hefty price tag, equal to the base price for a luxury Tesla Model S, but Boston Dynamics says, for that money, you're getting the most advanced mobile robot in the world. Although Spot is certainly nimble, its workload is mostly limited right now to surveying and data collection. Trial deployments have seen Spot create 3D maps of construction sites and hunt for machine faults in offshore oil rigs. Less routine tests include helping hospitals triage COVID-19 patients, and somewhat controversially, working with a police bomb squad. Boston Dynamics' pitch is that Spot is a multi-purpose mobility platform that can be customized with different sensors and programmed to perform patrols and inspections. Although the real goal is to send Spot to explore our solar system and help build thriving communities of other planets.